जनाब लेक्चर 2, इसमें हम कॉन्सेप्ट ऑफ OLS डिस्कस करने जा रहे हैं। बेसिकली है क्या मिनिमाइजिंग सम ऑफ स्क्वायर्स ऑफ रेसिड्यूल्स, है क्या विदाउट मैथमेटिक्स। तो ये मैथ्स में जब हम ये कहते हैं कि डिफरेंशिएट करने के बाद और फर्स्ट ऑर्डर कंडीशन के बाद सेकंड ऑर्डर कंडीशन के बाद जो A और B की वैल्यूज आती हैं उससे सम ऑफ स्क्वायर्स ऑफ रेसिड्यूल्स जो है वो मिनिमाइज हो जाता है। तो उस चीज़ को हम देखते हैं। Let we have hours of study and score students get, and we get its scatter plot. Fine, we rub the title, we just make an adjustment in axis instead of starting from 0 because you have minimum score 30, so it's okay. No, we go with this. You can rub these grid lines if you like. You can rub these grid lines if you like. We have intercept, we have slope. This is y hat, means score is your dependent variable, r's are your independent variable. Number of hours you study, your test score, your score improves. So I have taken this sample data intentionally so that we first of all understand this concept, then I will do the same what we are discussing, where the test score improves by reducing class size. So let's go and see. No, guess what is intercept here. You may guess 25, you may guess if I extend line here, extend line here, extend line here, you may guess it, let's say 25. Guess the slope. Slope is basically total rise, so 30 to 70, that's your total rise. Over run is roughly 5 to 30 to roughly 8. Fine. No, you have y hat residuals. No, instead of just take control F3 and you can name it from left column. Okay, no, instead of giving absolute references, I am going to use names. Intercept. Okay, fine. This is my intercept plus slope. This is my slope times yx, that is your y hat. Y is equal to beta naught hat plus beta 1 hat. What is your residual? Residual is difference between y minus y hat. That is your residual. We need these are sum of residuals. These are sum of residuals. We need to we have here sum of squares of residuals, and we need to fit this. Okay, look here, fit this line here. You see it's a bad fit because it lies below most of the points. If I take it 9, what happens? Okay, it improves a little bit. If I take it 35, okay, it goes little bit above. If I take 30, okay, no, what values of A and B should be taken so that this line passes from blue points as close as possible. This is the concept of minimizing some of the fitting a best line. How do we do that? There are so many values we can try, but we'll ask the computer that okay, pick those values of intercept and slope which minimize sum of squares of residuals. What is sum of squares of residuals? Okay, that's your sum of squares of residuals. Sum of squares of residuals. That's it. No, if you look here, if you take it 31, so sum of squares of residual comes 1562. If you take 30, sum of squares of residual is 1656. If we take 33, sum of squares of residuals further decreases. Similarly, you can say 8.5, sum of squares of residual further decreases. What those values should be picked? That's the name of the game. The formula which you use basically provides you intercept and slope value that this sum of squares of residuals is minimized. Let's do it through system. Go to solver. and use this. We need to minimize, not maximize, what? This sum of squares of residuals by changing what? By changing cells. Okay, these are the two cells. You want to pick these values and make negative, non-negative, okay, solve. Let's go see. So basically 43.11 is picked as intercept, and 5.09 is considered as the best slope, and sum of squares of residual is 858. That is considered as best line. So this is the concept of OLS. We try to pick intercept and slope values so that our sum of squares of residual is minimized, and that's what is mathematically. You take first derivative and put equal to 0 with respect to intercept, with respect to slope, and then you apply second order condition and you calculate those formulas. Beta hat is equal to covariance between x and y divided by variance of x. Intercept is equal to y bar minus beta 1 hat x bar. So those formulas basically provide you these two values. If we apply, even if you take it, I'm going to Linus case, we are going to regress scores on x, true, and control shift enter. So you see, you get the same values, 43.118, 5.09. These are considered as slope and intercept values. Thank you for watching. Take care.